Hello everyone and welcome to lecture series on data structure and algorithm. We are today going to see different approaches to sorting. I am Dr. Mangesh Joshi from Department of Mechanical Engineering. So our today's topic for this lecture is bubble sort. So in today's lecture we are going to see this bubble sort, which is one of the most basic and beginner friendly sorting algorithm. Although it's not very efficient for large datasets, but it will prove as a great starting point to understand how sorting works through comparisons and swapping. So let us begin with this bubble sort. So what exactly is this bubble sort? So it is a simple comparison based sorting algorithm. So this word is very important. It is a comparison based sorting algorithm. So in this, key idea is repeatedly steps through the list, compares adjacent elements and swaps them if they are in wrong order. So depending on our need, ascending or descending, it sorts the array or any data structure. So why this is called as a bubble sort? So like bubbles rising to the top in water, large elements bubbles to the end. So as bubbles rising to the top of the water, so similarly what happens in array is but this large elements get sorted to the end of the array. That's why the name bubble sort is given to this. So let us understand how bubble sort works. So first we compare adjacent items. Say for example first and second. If there are two items, suppose let's say 7 or second is 10, then maybe 13 or then maybe 15. So first step is to compare adjacent items. So suppose 7 and 10 is compared. So suppose if first one is greater than the second, then swap. Now this is arranged exactly in correct order. So there is no need to swap if it is greater. If it is 17 for example, then this will be swapped. Now we have to repeat this procedure for every pair until no more swaps are needed. Right? So we have to repeat this for every pair until what time you have to do? Until no swaps are needed. Right? So first we compare adjacent elements, for example first and second. If the first one is greater than the second, we swap them. We then move to the next pair and do the same. We keep repeating this process till we reach the end of the list. Now after one pass is complete, the largest number reaches to the end. Right? So this is an iterative process. In one pass, the largest element will be at the last in the list. After one pass is complete, the largest number reaches to the end. Hence, then we repeat the same process, right, for the rest of the list, excluding the last sorted element. So whatever remaining array will be there, we will be again doing the same process, excluding the last item, right? So in this way, the bubble sort works. This is again given or explained with the help of an example over here. So suppose, so this is pass 1 is shown. So if it is a given that this is the unsorted array 7, 12, 9, 11 and 3. Step 2, compare first two elements 7 and 12. Since it is in correct order, no need to swap. Then third step, compare next two elements. Since 12 is greater than 9, then the swap is needed. Hence, this is inserted here, this is inserted here. So after resulting swap is 7, 9, 12 and remaining 2 as it is. Step 4, compare 12 and 11. Again 12 is greater than 11, so swap is needed. So after swapping, you are left with 7, 9, 11, 12 and 3. Step number 5 now is compare the last pair, that is 12 and 3. Since 12 is greater than 3, the swap is required. And finally, after the first pass, as I just told you, the largest element will reach or bubble up to the end of the array. So result after pass 1 is the largest value 12 is now at the end. Pass number 2. Now at the end of the pass 1 we have this array. For pass 2 again we will start with first two numbers. If first is lesser than the second, no swap is needed. Then we will compare 9 and 11. Again no swap is required. Then we'll compare 11 and 3. Right? So in this case swap is needed. So this element is here, comes here, and this element comes here. So after second pass, you have second largest element, which is 11. Right? So now this will be performed in only this element. So third pass will be performed for 3 elements, 7, 9 and 3. So again we will compare 7, 9, it is in correct order. Then next 9, 3. So swap is needed and hence it is swapped. And resulting array is 7, 3, 9, 11, 12. So this is the end of the pass 3. Again we will go for pass 4. And finally 7 and 3 will be swapped. So now you have got the fully sorted array. So in this way the bubble sort works. So to implement bubble sort, what you need? So to implement the bubble sort algorithm in a programming language, we need an array containing the element to be sorted. So an inner loop that iterates through the array. So inner loop will access or traverse through the elements of the array, comparing adjacent elements and swapping them if the current element is greater than the next one. With each pass, loop processes one fewer element as the largest values bubble to the end. Since after pass 1, the next loop or next iteration will be for n minus 1 times, because you have already identified the largest value and which has reached to the last position in an array, right? Then third, you require an outer loop that determines how many times the inner loop should run. For an array size of n, the outer loop should run for n minus 1 times to ensure entire array is sorted. Right? So these things you require while programming the bubble sort. The bubble sort program is given over here. So you need to include stdio.h file. Then you have created an array having 7 elements. So using this size of operator and size of function, you have calculated the number of elements in an array. Then these variables you have declared. Just to print an original array, you have given this block of statements. This is actual bubble sort implementation. This is outer loop, which we have just discussed, right? Then this is inner loop for comparing adjacent elements. So here you can see it is comparing adjacent elements, and this swap variable is calculating for how many number of times the swap is done, right? So this is the basic bubble sort code. So if no swaps occurred, then means the array which was given as input was already in a sorted order. So that's why this variable is here. So to print the sorted array, again we have given some block of codes. So you can just type all these codes. This code is for swapping. You already know how to swap variables. You have already learned this in programming for problem solving, right? So I will not discuss this over here. So if you type this code, you will get correct order, right? So let us see what are the pros and cons of this bubble sort technique. So it is simple to implement, easy to understand. You can basically visualize this how the bubble sort works. Then cons includes very inefficient on large datasets, because if the array size is large, so it will compare each and every part, right? So it will take a lot of time complexity. So basically it has time complexity of O, this is from big O notations, n square, right? So it will take a lot of time on large datasets. So to bubble sort, better alternatives exist like merge sort, quick sort, etc. So this bubble sort is basically useful for smaller problems or teaching purposes. It's rarely used in real world applications. So that brings us to the end of the lecture on bubble sort. I hope you have now a clear understanding of how it works, how to implement it, and where it fits in the world of algorithms. Right, so in our next lecture, we will explore more efficient sorting methods that are widely used in practice. So thank you for watching this video lecture. Feel free to reach out if you have any questions. See you next time and have a nice day.